In this video, I'm going to take you through exponential growth modeling. So this example we did in class where you deposit money in a savings account, it receives 5% interest, and we want to know if we deposit 400 into the account, how much is at the end of a year. So we could do 400 times 0.05 to get the amount of money we're getting each year, but then we have to add that to how much we deposited. So total in the account at the end of a year is 420, and that's simple enough. But what if I said at the end of 6 years? We don't really want to do this over and over 6 times. So we could combine it all into one step by taking 1 plus the rate and getting 1.05 times 400, and that would give us the same thing. So we get this formula that looks like this: PV, which stands for present value, and then FV is future value. And we do 1 plus because we're growing, our money's growing, and then T is the amount of time. And so that goes into the exponent. So that's why this is an exponential growth model. R is the interest rate, or the rate at which something is increasing, and T is time, depending on if it's years or hours or whatever. So let's look at another question. What if, how much money is in the account after 6 years? What would we have to do? Well, we plug in everything into the formula, we change the T to a 6, and now to calculate this, we should do the 1.05 to the 6th power first, because we do exponents first, and we get about 1.34. But I don't want you to round this yet, because now we need to multiply by 400 and then round the answer to about 536. If we wanted the change, it would be 0.038. So then if I was actually rounding money, it would be 0.044 cents. So it's important to round your final answer. Don't round this part, because then it will be off. Like, what if I rounded this just to 1, and then I do 1 times 400? I'm saying there's only 400 after 6 years? That's not even close. So definitely don't round too soon. Okay, example 2. 250 was invested at an interest rate of 3% per year, so that's 0.03, because 3 divided by 100. And then we want to know how much is in the account after 9 years. So we plug everything into the formula. 250 is the present value, 1 plus 0.03 to the 9th. And again, do 1.03 to the 9th first, and do not round this number. You get 1.3047, so on. Then multiply that by 250 using all those decimals so that we can then round our final answer. Example 3, population of a town is increasing at 2.5%. So divide that by 100 and you get 0.025. That's going to be R. Okay, and then we want to figure out, let's see, at the end of 2005, we're told the starting, like the present value of residents is 6,500. How many were there at the end of 2010? So from 2005 to 2010 is 5 years. So T equals 5. And present value was 6,500. So we plug everything in, and we want to do the 1.025 to the 5th first. 1.025 to the 5th power is about 1.13, and use all those decimals and times it by 6,500 to get 7,354. Now, since this is people, we really shouldn't use the decimal here. We don't want to have fractional people. That's kind of weird. Oh, okay, last one. Number of students out of school are getting the flu. It's increasing 12%, so that's 0.12. At the beginning of Monday, there were 56 students. So then we're going to go to Tuesday, Wednesday, Thursday, Friday. And it says, which of the following is closest to the students who have the flu on Friday morning? So the beginning of Friday. So we're only counting Monday to Tuesday is 1 day. Tuesday to Wednesday is 2 days. Wednesday to Thursday is 3. And Thursday to Friday is 4, because we're counting at the beginning of Friday. So T is only 4 in this case. So then we plug in to our formula 56 initially, 1 plus 0.12 to the 4th power. Okay, 1.12 to the fourth power is 1.57, and then we multiply that by 56 times 56, and we get about 88.117. So this is closest to 88.